Hey everybody, sorry it's taken me a while to get a video up. My microphone was messing up and I've kind of got it figured out, but I'm still working on it, so hopefully the sound quality is okay. And I definitely miss you guys, and I hope everybody's doing okay and working on NTI, and we're going to get back to school before we know it and get back to learning. So with that said, we got line plots, and one of the questions on the practice said Mr. Rice's students ran the 40-yard dash in the following times in seconds. And they give us all this data right here. And then down here I have a line drawn to give us a line plot. We're going to build a line plot in a second. So we got 6.8, 7.3, 7.1, 7.0, 7.3, 7.0, 7.2, 6.9, 6.9, 7.1, 7.1, 7.2, 7.1, 7.0, 7.1, and 7.2. So the first question it asks is how many race times were recorded. So each of these times right here, this is a student. So like this right here is one student running the race. This is another student. This is another student. So in a moment when we record this data down here, each point that we make on the line plot, it's going to represent a person, a student in this case from Mr. Rice's class. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we got 16 times recorded. And then if you were given a question to create a line plot from this data, and you just had a blank line down here, and you didn't know necessarily what to start this number down here as, would you start the number at 0? Would you start it at 1? Would you start it at 2? What would you start it at? And what would you go up to? Would it be 20? Would it be 100? Would it be 10? I mean, those are all questions that students bring up whenever we're talking about, you probably hear in the background an airplane. I'm out in my shed recording this. It's like an old school prop plane went over. Sorry, squirrel. I'm back. Some things never change. Even if I'm recording a video, I'm still going to get off task just a little bit. But anyways, from here to here, what do we start at? What do we end at? And we get that from our data. We look in here for the smallest number. And it doesn't have to be exact, but just by glance, I think my smallest number is 6.8. Do I got a 6.7? No, so 6.8. And then my largest number, 7.3. Yep, 7.3. And then from 6.8 to 7.3, I'm just going to go 6.8, 6.9, 7.0, 7.1, 7.2, and then 7.3. And it doesn't have to be exact spacing, it's just to represent data. And then at each of these individual, and I think I have another colored Sharpie out here. Do I? Yeah, I do. Ta-da! At each one of these, hopefully this will show up. We'll see. Each one of these places, I'm gonna put a dot to represent the person. So at 6.8, we got one little dot. That's not that bad. Okay. At 7.3, I have another dot, and I'm gonna try to keep these like in the same like little box spaces right here. At 7.1, I have a dot. See how they're like all in that same row of boxes right there? 7.0, I have a dot. 7.3, I have another dot. 7.0, I have another dot. 7.2, I have a dot. 6.9, I have a dot. Another one at 6.9. One at 7.1. Another one at 7.1. 7.2. And we know that's 7 and 2/10. I'm just making it, just saying 7.1. just for conversation. 7.1, there's another. 7.0, there's another. 7.1, there's another. And 7.2, there's another. Make that a little bigger. Okay, so now I got all this put down here, and I have my data laid out here, and now I'm asked the question, which time is most frequent? Like, which time or which number down here or which piece of data has the most entries or occurs most often? And that's obvious at 7.1, because if you did it correctly and you make sure that you're putting your dots evenly spaced, and then you can tell from from a graph. Also, it creates a little bit of a curve. Okay, it creates a little bit of a curve. So most of the data falls underneath this curve right here. And some of the questions like that I saw in some of the practices asked about an outlier. So an outlier in the data would be something that doesn't fit within this normal data set. And people are like, well, how many places off? Like how many? Like what would that be? 8? Would that be 9? And I say a good rule of thumb is like 3 or more, or 3 or less. Like, so 3 this way or 3 this way away from the data set. Like, for example, if another person ran it and they came in here and they was just like this superstar, like, prodigy runner, like, and they did it in 4.4, we would all be like, sign that kid up. He's doing it. And it would be way down here, if someone ran it and then stopped halfway through and started picking dandelions like I probably did when I was a kid, there'd be like 19 seconds, like 19.1, and you'd be like, oh man, like, don't give that kid a racing job, if there's a job racing. But yeah, so these would be outliers right here. And yeah, that's line plots. Make sure to comment on this if you have any questions, and look forward to more videos coming up. See you guys.